what you have to do is to go to analyze. Go to analyze. I will show you now. Go to analyze. Compare mean. Analyze. Compare mean. Compare mean, and it's right here. So the other one that we did the other time for descriptive statistics is on descriptive statistics frequency. Now for independent t-test, when you have two groups that are numerical data, the two of them must be numerical data. Now you then click on independent sample t-test. Independent sample t-test. After you have clicked on independent sample t-test, then you key in your variables. So after you key, let's say you want to check whether hours spent influences um, um, I'm not doing it that way. They are all string data. So let's do it this way. But basically, what I want you to know about independent sample test is that it is used to compare between two groups. Why one way ANOVA compares between more than one group. You can use that one for this study. So, and it's right here. This is independent t-test, and the other one is one way ANOVA. So for one way ANOVA, key in you want to use them to compare the mean of the two variables. So we key in the gender, and then the level. Let's say you want to compare the CGPA. The CGPA. So when you have more than when you compare between three or more groups, and the CGPA, so let's say comparing group, level, let's say level, academic level, comparing factor, CGPA. Yeah. So now to reporting data. It's very, very important for us to know how to report uh, our data. So let's start with the descriptive statistics. Let's say we have this data here. We just pull it out from the Microsoft here. Let's say we have this data here, the gender of the respondent, or let me pull out all the data that's so you can just like the way I explained it the other time, you can just click on descriptive statistics, frequency, then you key in everything. Please remove the respondent number so that that one will not okay. Then we have everything here, so I can just copy everything and paste it on a Microsoft Word. You can just do that for your own project work also. So for descriptive analysis that most of us will be working on is very, very simple, other than testing of hypothesis. The same thing, testing of hypothesis is very simple. The first thing you need to ask yourself is that how many variables am I testing? Am I comparing mean between two variables? If that is what you are doing, then you will use t-test. If you are comparing between more than three groups, right? If you are comparing more than three groups, you will use the two-way ANOVA. Now, for the descriptive statistics, let's start from there. This is the data. This is the data gotten from SPSS. Now, this is the data gotten from SPSS. Okay, let me check from here. This is the data gotten from SPSS. So you already have your table. Let's start with gender. So all you have to do is to just tell us the table above represents the gender of the respondent, right? And of course, when you are reporting data, what we can see on the table, we're not supposed to repeat it again. Of course, we can also read the table. You're not supposed to tell us that 241. So we're supposed to report that majority. This is, look at the percentage now. We have 53.9% of male respondents and 46. So which means that it is not far-fetched. It is not too much. So the two of them, they have it's not more than, so you can even just put it on ChatGPT to interpret it for you. So let's have something like new chart. Let's see what ChatGPT will bring out for us. Interpret this table without repeating what is on the table. So let's hold on. So all that is visible on the table, we are not supposed to repeat it again. So just tell us okay, let's wait for, not in this case, it is not that majority of the respondents are male or are female, but quite a number of them are. So we have more male. So in front of the more male, you can put 53.9% are male respondents and 46.1% are female. So which explains that there is a balance in the respondent gender ratio. It's not that male are more excessively more than female, or they are lesser than uh, female. So then we have the age. This age shows that out of the whole age, we have 18. For 18 years, we have 13. For 19, we have 50. For 20 years, we have 72, and so on and so forth like that. You can also report this in that same manner. So, but whatever you can see, the same thing for academic level. You can see this academic level now. The percentage of each and every respondent falls within 21.7, 20.4, 20. So you can say that 400 level, so 300 level has the highest number of respondents, with followed by followed by the 300 level has number at the highest number of respondents, followed by the 400 level, then the 200 level and the 100 level. Then we have the hours spent. So majority of the respondents spend 3 hours, which is 21.7% daily on social media, right? And that's how you respond, you report it. And the total number of hours spent by respondents falls between 1 to 2 hours daily, representing about you can add this one and this one together and say and report it like that, representing this particular percentage, right? So we can say 1 to 2 hours, uh 1 to 2 hours daily, while some spend for, okay, I think we have 4 hours here. Yes, 4 hours. You report it just like that, report what you have seen. So for social media influence on academic performance, so majority of the respondents, uh slightly uh uh about 53.9% of the respondents report that they spend that social media have negative. More than half of the respondents, yeah, reported that social media have negative influence on their academic performance, right? And they you can, when you check this one also, you can see it is also a correlation from what you have there, that academic performance, their perception that after exposure to social media content, not just exposure, that generally their perception about their academic performance is somewhat declining. And when you check when you check when you do a t-test analysis of social media influence on academic performance and academic performance perception, you can see it will be statistically significant. That social media, you can then come to the conclusion that social media has negative influence on the academic performance and even their perception of the academic performances. So that's how you report it. But however, when you have for correlation analysis, t-test, how do you report that? It's also very, very simple to report. It's also very, very simple to report. If the p-value is less than 0.5, you will report that the result is significant. You report that the result is significant. So you can simply say that uh, you can simply say that you can simply say this in this way: the results reveal a significant relationship between social media usage and academic performance, right? Because the p-value is less than 0.05. You can even give us the exact value of the p-value, that the p-value is equals to 0.001, like the one we have, the 0.000, the one I showed you the other time, right? That the p-value is less than 0.05, right? So when the p-value is less than 0.05, it is significant. There is a relationship between the two variables you are comparing. But when the p-value is higher than 0.05, let's say you have 0.06 or 7, so it is telling you that there is no statistical significance between the variable. So if you want to report the test, you say the analysis shows a significant difference between male and female student academic performance. That's how you report it, right? That the analysis showed a significant difference in academic performance of students, as p-value is less than 0.005, right? It's less than 0.005, and that is very, very simple to understand. Very simple to understand. So just like as I've explained, Just like as I've explained, let's start with the descriptive analysis. The data is not. So to describe data, which is basically what you'll be doing mostly in your study, you want to summarize the data, you want to, you know, organize the data. So the first thing you do is to go to analyze, descriptive statistics, frequencies. So when you have gotten to frequency, you can select all the variables and then click on analyze, but you can pick them one after the other, one after the other. Academic level, okay, and it will bring it up like this. So it's now left for you to interpret it. It's now left for you to do the interpretation, which is 100 level. We have 21%, 24% 0.7 at 200 level, 27.2% at 200 level, 400%, 26.7%, and so forth and so on in that manner. So you explain this this particular percentage, this one here, you use that percentage. You can also use this valid percent, but this one is better. You can see it's even the same thing to do your interpretation, and that is it. That is it. So for those of us that will be using Excel for our analysis, I will advise that you do the coding on Excel, right, on your phone, Abby, and then you look for somebody who has SPSS to do the coding for you. It's just the whole work lies in how to do the coding appropriately, how to do this, particularly this variable view, like this particular variable view. So, and it's very simple. When you take your questionnaire, you look at your questionnaire critically. Look at your questionnaire critically. If you have 30 items on it, most times you don't need this one, this ID, but I usually advise students to put the ID there, because ordinarily this can also survive as your ID. All these ones that you have here, this number one, this one here, you can see this ID one, this one here, this 2, 3, 4, 5. So already ID on it. So if you delete this one, if you remove this one from it, it will still be, you can see number one, number two, show you the number of the questionnaire, right? So